Hi everyone, this is Asma Mushtaq from the EEVIBES, and in this video lecture you will learn how we can actually find the adjoint of a 3 by 3 matrix A. So let's assume that we have a matrix A whose entries are 2, 3, 1, then 0, 1, 5, and the last row is 6, 1, 0. Okay, so in order to find the adjoint of a 3 by 3 matrix, we will need the values of the cofactors and the minors. Okay, so adjoint of A can be represented as a rectangular or a square matrix A whose entries will consist of A11, A12, A13, then A21, A22, A23, A31, A32, and A33. And ultimately you will have to take the transpose of it as well. All right. In order to find the A11, we need the information of the cofactor and the minor. So A11 means minus 1 raised to power this order 1 plus 1, and then you will keep the first row and the first column. So excluding the first row and the first column, what you will have 1, 5, 1, 0. So you will have to write this matrix but in the determinant form. So that will be 1, 5, 1, 0. Since you know that minus 1 having even power, and here you will find the determinant by cross multiplication of the diagonal entries. So 1 into 0 will result in 0. Then this negative sign of the formula, and then 5 into 1 is actually 5. So minus 1 raised to power 2 is actually equal to some positive number, that is 1 in this case, and then 0 minus 5 is actually minus 5. So A11 comes out to be minus 5. So in this way we have found the first value, which is A11. Then the second value A12 can be found by minus 1 raised to power 1 plus 2 now from here. Then we will keep the first row and the second column in our matrix. So let me just select that area for you, and next time we will keep doing directly. So by skipping the first row and the second column now, what we have 0, 6, 5 and 0 in this case. All right, so minus 1 raised to power, it's an odd number now, and here you will do what? 0 into 0 is 0, then minus 6 into 5 is actually equal to 30. So this becomes minus 1 since it's an odd power, and then minus 30, which becomes plus 30. By doing the same procedure, you can find all the values like A11, A12, A13, A14. So here it can be seen that I have determined all the values of A11, A12, A13, and similarly here you can see A21, A22, A23, and then A31, A32, and finally A33. I have written all these determined values over here, and now let's see, we will substitute these values in the matrix A, and these were the rows basically. So minus 5, then A12 is actually 30, so 30 over here, and then minus 6, then A21, which is 1, then minus 6, and then 16. Similarly, A31 was 14, then minus 10, and last entry is 2. And finally, we have to take the transpose of this matrix now. So the steps for finding the adjoint will be completed then. In order to find the transpose of a matrix, let's assume that if A is equal to, or A bar, this is some other matrix, it's equal to 2, 1, 3, 5, then the transpose of A bar can be found by switching the rows into columns and columns into rows. So this row will be written as a column vector over here, and then this row will be written as the second column vector. So this is actually the transpose. Now, in order to find the transpose of this matrix A, and to get the final result, which was the adjoint of A, we will take the transpose of it. So first, this row vector will be written as a column vector, minus 5, 30, minus 6, then 1, minus 6, and 16. And last row will be written as 14, minus 10, and 2. And this was the final answer of the adjoint of A. If you have more questions, you can drop your questions in the comment section. And also don't forget to like and subscribe to my channel, EEVIBES. Thank you for watching.